Hello and welcome to revision classes on television. Today, we will be having a session in mathematics. Our guide is Abiodun Idowu and our topic today is circle geometry.
Circle geometry questions involving the application of the theorems. Now, we have questions on the board. For this particular question, number 1, we are required to find the angle RTS and SRP. Angle RTS, this is RTS. So let me mark it. This is the angle they asked us to find for RTS. The second one is SRP. SRP. That means there's supposed to be an angle here. So I will start by joining R to S. So I'll start with that. Join R to S. So I'll place my ruler and join the 2 points as shown on the board. Now, the second point, SRP, is now well pronounced, SRP. So this is the second point we are looking for. Now, at this point, I'm going to use a letter to denote what I'm looking for. So I can say, let angle RTS be X and angle SRP, let it be Y. So I'm going to put that in my diagram. This is X and this is Y. I still have another point I may like to refer to. Let me refer to this angle here as angle K. That is angle TRS. So I can say, let TRS be K. So at this point, I'm ready to look for Y and X, because Y stands for RTS, X stands for RTS and Y stands for SRP. Now from this arrangement, looking at angle K is going to be the same as angle 65 because both angles are in alternate segments. So when they are in alternate segments, they are equal. So I can write that angle K is 65 degrees. The reason for that, angles in alternate segments. So we've been able to get the value of K. Looking at the diagram again, angle Y and angle K lie on a straight line. And we know that the sum of angles on a straight line is 180 degrees. So we are going to use that theorem to proceed. We'll say angle Y plus angle K is 180 degrees. The reason for that, sum of angles on a straight line. We know that K is 65, so we have Y plus 65 degrees is 180. So that implies that Y is going to be 180 degrees minus 65 degrees. So this implies that Y is going to be 80 minus 60 is 20. So we have 115 degrees. So we've been able to find the value of Y. And Y stands for angle SRP. So we are done with this. The next thing we are looking for is to find the value of X, which stands for angle RTS. So at this point, I'm going to look at the triangle TPS. That is this particular triangle here. Looking at that triangle, this is the exterior angle of the triangle. I can say X plus 34 is going to be 65. The property I'm using is the property of a triangle that says that the exterior angle of a triangle is equal to the sum of the two interior opposite angles. That is, X plus 34 is going to be the same as 35. If you look at it, I'm considering the triangle TPS. So in that case, I'll say X plus 34 degrees is 65 degrees. The reason for this, exterior angle of a triangle. So at this point, X is going to be 65 minus 34 degrees, and X will be 5 minus 4 is 1, then 6 minus 3 is 3. So X is 31 degrees. We've been able to find the value of X that represents angle RTS, and we have also been able to find the value of Y that stands for angle SRP. Looking at this question, I have to join point R to S so that angle SRP can be pronounced. And after joining the 2 points, it is easier for me to find the angle SRP. And the theorems I've used there, I've used the theorem of angles in alternate segments. I've also used the theorem concerning the sum of angles on a straight line being 180 degree. And likewise, I've used a particular theorem that is applicable to a triangle. That is, the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So we've been able to find the two angles the examiner required of us. Put this in your notes and take time to study it. In this particular question, we are required to find angle WYZ. So the angle we are looking for is this angle here, WYZ. Now, I'm going to denote that angle we are looking for by X. So I can say, let WYZ be X. I can also look at this angle here. That is angle VYW. VYW. Let it be M. So this angle here is M. So after doing that, we can now continue so that we can find the value of X. How do we find X? Look at the angle here, this particular angle, which is angle YWZ. Angle YWZ is the same as this angle because both of them are in the same segment. So this angle is 52 degrees. So I'm going to write is 52 degrees. Angles in the same segment. Now, another thing that we can see, looking at the triangle VZY, the length VZ is the same as the length ZY because of this symbol that shows that this length is the same as this length. That implies that we are dealing with an isosceles triangle. And we know that the base angles of an isosceles triangle are equal. That implies that this angle here must be the same as the angle in this region. But before I will go further, I'll try to find the value of angle M. Looking at triangle XYW, triangle XYW, I can say angle 20 plus angle M is going to be 52. That is the exterior angle of a triangle. So I'm going to write it down. 20 plus M is the same as 52 degrees. Exterior angle of a triangle. So at this point, it's easier for me to find M. M is going to be 52 degrees minus 20 degrees. And that implies that M is going to be 32 degrees. So we've been able to find M now. Then I'll now go back to the previous point I've made, that this triangle is an isosceles triangle and the base angles are the same. That is 52 degrees is going to be M plus X. So I can write that, okay, M plus X is going to be 52 degrees. Why are they equal? Because both of them are the base angles of an isosceles triangle VYZ. So I'll write base angles of isosceles triangle. So from here, we know that M is 32. So 32 degrees plus X is 52 degrees. Making X the subject, X is going to be 52 degrees minus 32 degrees. And that implies that X is 20 degrees. In this question, we have been able to find angle WYZ, which we denoted by X. We have used the theorems involving angle in the same segment, exterior angle of a triangle, and then the base angles of an isosceles triangle. We have come to the end of this particular question number 2. We have been able to find the value of X. Now moving on to question number 3, we have the diagram, and in this diagram we are required to find the angle STO. Looking at this, this is the angle XTO. STO, that is the angle we are looking for. Now I can say let angle STO be X. So I'll write X in that region, X. So we are looking for that angle. Now I can also say, for easy reference, angle ORT, let ORT be M. So this is the angle ORT here. ORT. So this is M. So after putting all those in place, all those in places, we now look at the theorem that can fit into this diagram. This is an angle at the center, and this is an angle at the circumference. So the angle at the center is going to be 2 times the one at the circumference. So in that case, I'm going to say angle ROT is going to be 2 times angle 46. Reason for that, angle at center is twice the one at circumference. So that means ROT is going to be 92 degrees. That is, this angle here is 92 degrees. Now, after getting that, we now look in the direction of the fact that OR and OT, they are radii. That is, they are equal in length. So I'll write that OR is the same thing as OT. Both of them are radii. And that implies that we are dealing with an isosceles triangle. So in this case, I can say M is the same thing as 29 plus X. That is, this M is going to be this angle. Both of them are the same because they are the base angles of an isosceles triangle. Base angles of isosceles triangle. So after getting to this point, the next thing we'll do is to find the value of M by considering this particular triangle. Adding all the angles together must give us 180. That is, this angle, which is ROT, plus angle M, plus angle X, plus angle 29. How do we do it? We know that X and 29 are the same as M. So instead of writing X and 29, I can just write it as what? M. So in that case, I can say angle M plus another angle M, then plus 92, all will be 180. That is the sum of angles in a triangle. M plus M is 2M, is going to be 180 minus 92, and that implies that 2M is going to be the same as 88 degrees. So at this point, we can say M is 88 divided by 2. So M is 44 degrees. So if M is 44 degrees, X plus 29 will also be 44 degrees because both of them are base angles of an isosceles triangle ORT. So I've written it here already. So I'm just going to quote it. M is equal to 29 plus X. So our M is 44. 44 is 29 plus X. We've already mentioned the reason. They are base angles of an isosceles triangle. So this implies that X is going to be 44 minus 29 degrees. So at this point, X is going to be, that is when you subtract 29 from 44, we are going to have 15 degrees. So on this note, we've been able to find the value of angle STO. which we have denoted by x. Take a look at the solution on the board and then put the solution in your notes for further studies. We are required to find angle M plus angle N. This is the diagram we are given. This is M and this is N. So looking at this diagram, let's look closely at this angle here. That is angle RQM. Angle RQM is in contact with the tangent PM. And at the same time, this is the center of the circle. So the radius is in contact with the tangent. And we have said earlier on that at the point of contact of the radius to the tangent, the angle is 90 degrees. That is, the radius is perpendicular to the tangent at the point of contact. So because of that, this angle RQM is going to be 90. So I'm going to write the reason down. RQM is 90 degrees. The reason: radius is perpendicular to tangent at point of contact. Now, looking at triangle PSQ, we can say angle M plus angle N is going to be 33 plus 90, using the fact that the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So I can now say M plus N is going to be 90 plus 33 degrees. The reason for that: exterior angle of a triangle. So that implies that M plus N is 123 degrees. So we've been able to answer this particular question. We are required to find the value of M plus N, which we have done. We used the theorem that talked about radius being perpendicular to the tangent at the point of contact. And at the same time, we look at the theorem that talked about the exterior angle of a triangle. On this note, we have come to the end of today's lesson.
You can subscribe to NTA series on YouTube to watch or download past episodes of revision classes on television. That's the much we can take on the program today. Do join us next time for another educating session.